Okay, I gotta make it very, very short. I only have 15 minutes, so I'll go over it very, very quick. What I'm talking about today is NOBAD. NOBAD is a volunteer effort done by a couple of people who work at different companies. Basically, what we're doing is we were trying to build a aggregator for network health signatures that over the course of a week, a month, a year, can learn what's normal in terms of network behavior and alert the right person at the right time about deviations from what Joe Random Network Admin would call norm. This whole thing started about 3 years ago when I had the same problems that about 90% of the people in this room will have. It's Friday, it's 7:30, you're sitting in front of the TV watching South Park, and the phone rings. It's a NOC driver telling you that the network is down, the internet is broken. The first thing I would do is call Al Gore and ask him what is so broken about his internet, but, well, usually it's a customer calling in, he can't reach his website. Can have a lot of reasons not to be able to reach the website, and routing is usually the least of the problems that can occur. So despite the fact that the average person likes to talk to backbone engineers, we're usually not the guys who are in charge of this particular problem. So what we needed was a pre-qualification mechanism, a mechanism that could go ahead and look at certain situations in the network to find out if it's actually a problem that we have, if it's a problem that's somehow associated with DOS, DDoS, routing loops, somebody pulling a line card out of a 12,000 or whatever. I've been asked before, and I just filled in this slide. The slide is 5 minutes old. I've been asked before if we're a DOS prevention tool in any kind, and well, ladies and gentlemen, I'm here to present you the only hardware device to reliably stop DOS. It's also the only hardware device to use Darwin approaches and stop the replication of DOS kitties. This is the most complex diagram I've ever drawn in my life, and I beg your pardon if it looks a bit screwed up. Well, what I'm trying to demonstrate with this diagram, and it's so complicated not even I understand it anymore, is the way we go in the collection of data and what NOBAD is all about. NOBAD consists of three main infrastructure points. There are so-called sensors, there are aggregators, and there's an engine. The sensors can be deployed on workstations, the sensors can be standalone machines or computers, or the sensors can be built in part of a vendorware appliance. Those sensors have only one job: to take logs, log files, status reports, do a show tech on a router, and translate all those information into an easily readable XML format and pass it on to the data aggregators. I've listed a few things there. We've got workstations that, let's say, HTTPD, INND, whatever. We've got policy enforcement points, PEPs, such as firewalls, IDSs, router ACLs. We've got routers that CFlow-D, NetFlow, and we've got whatever you got in your network, load balancers, LTONs. All these devices generate some kind of log. At least I'd hope so. If I get a device that doesn't generate a log that I'm able to push onto a machine somewhere outside of that device, it's not worth deploying. So all these devices generate some kind of logs. The idea of these sensors is to get those logs, translate them into XML data, and push them onto the data aggregators. The data aggregators consolidate this information and calculate what we call normality. We prefix normality with a $ to denote the variability of normality. Normality is not a static factor. The big difference between us and other commercial DOS detection and prevention systems is that we do not deploy static thresholds. We are trying to learn over days sometimes weeks or years, how the network looks like, how traffic comes in over the day, where our traffic peaks lie, where our main peering points lie, where, well, if you deploy, for example, Yahoo and Choshmo incorporated in one net block, there's no question who gets more traffic, and it's definitely not unnormal that part of this network behind the router is pretty unevenly saturated. All this information is being consolidated and being pushed onto an engine. This engine draws patterns from a database. The patterns in the database basically represent things we've done before. For example, a couple of weeks ago, we had a little attack that saturated this line to 99%, and we had a traffic spike, we had a router spike, router CPU 99%, and what happened is this guy ran and fixed it. This is information that we have to give back to NOBAD after we fixed it, but NOBAD keeps this information in a database, and the engine is supposed to, and as usual, we're fortunately not a commercial entity, so we can admit that it still has flaws, but we're working on that. This engine finds out, okay, this is no longer normal, and pushes it on to an outcome agent. The outcome agent determines whether to alert a NOC driver, whether to alarm the client, whether to inform the routing group or whoever. This is how the collector output looks like, and I thought I'd just include one of those. This is the XML information that comes from one of our sensors, XMLized towards the aggregator. And if you look down, you get a data 192.168.1.1. There's a T1 router with a high criteria, with a high critical factor. So in other words, if that thing is gone, well, tough luck. And the sensor is a simple where command. It's an Python expect-based thing. We tell it in, we issue a where command, and no data came back. Data is null. In other words, we might have a problem here. This is how the data collection works. We have senders that send, for example, syslog information. We've got appliances that we have to go in and grab information via expect. A good example for that would be Altion load balancers. They give us logs, but those logs are not as informative as going on there and issuing a set of commands and getting the output. We've got applications that we can query via SNMP, and we've got proprietary applications. I don't like proprietary applications in log formats, but you have them. All these information is being gathered by sensors, then pushed on to port 3443 on an aggregator. The aggregator normalizes them, strips off what, it's just not important, XMLizes them, and pushes them on. Here's the basic functionality. We collect data from a number of independent devices. An independent device could be a Cisco router, could be a Foundry, could be a Juniper, could be an Apache web server, or could be something as complicated as an IRC server. We aggregate all this data into representation of the current state. In other words, we get a pretty good idea how the network looks like right now. We've got a lot of hits on one web server. At the same time these hits go up, we have an increase in load from our border here to the server there. And in addition, a CPU spike on one of the routers. It's something that is at least worth looking into, but the first person who should look into that is the admin of the web server, not us. And unless it affects our network, of course. We compare that state to what we've collected over the past couple of weeks, months, years, and called normality. Normality is really, it's a healthy median of what we've seen so far. And if they are sufficiently equal, we just continue. We don't touch that anymore. If they're sufficiently different, we start analyzing them. I'll come to that later since we don't have that much time. Okay, analyze. Analyzation process could include: do these values exceed given thresholds? Of course, we have a way to submit thresholds into the evaluation process. In other words, the saturation on this link should not exceed 80%. We've got a lookup mechanism that checks out if the change is significantly high enough, even though it does not exceed thresholds to be noteworthy. We're looking at past occurrences. What has happened before when something equal to that happened? Every time a case that NOBAD opens is resolved, and we've got a web front end for that, we're walking the resolving entity through a questionnaire, and NOBAD is learning those informations. In other words, the last time we exceeded 80%. What was I told it was? NOBAD is pretty good in learning that. Of course, NOBAD has kind of an escalation process built in, and that's one of our weak points right now. Who needs to be made aware? In other words, we could actually give them a list of people that need to be paged if something happens to this particular set of network infrastructure. What means of alarm do we have? At 4 o'clock in the evening, in the night, it's definitely not a good idea to just send an email. You want to page, or you want to do something a bit more awareness raising. And what could be the possible root cause? In a possible root cause, we go from the detected symptoms up to the borders and try to find out what in this path of data travel from our symptoms to the border might cause this problem. A lot of so-called DOS and DDoS attacks are, at least today, not really DOS or DDoS attacks, but somebody not knowing how to issue the right commands in the right router. Happens every so often, and it would be a good idea if I don't get paged out of bed at 4 o'clock in the morning. If somebody else in Tokyo had just a stupid idea and tried to follow up on that one. Okay, let me go back one and just talk 5 seconds about these two use cases, and I want to talk about the first one, especially since before lunch break I saw this nice little graph on the wall with infected hosts, infected machines, and Code Red and T-Dial-In, one of the infrastructures we actually deployed NOBAD, seemed to have been almost unaffected by Code Red version 2 and NIMDA. They were affected as you and I were. In our actuality, they were much more affected than most of the American hosts. Germans are not more security aware than anybody else, and looking at me, nah. T-Dial-In has NOBAD installed, and after a couple of minutes of that happened, NOBAD detected one thing that was completely deviant from normality. All of a sudden, machines that had never accessed port 80 outside started doing so. This is clearly a deviation from what NOBAD had seen for the couple of weeks before that. So NOBAD alerted the right person. In that case, it's an outgoing HTTP request, abuse, security, and routing was informed. Those three guys sat down, or those three groups sat down and started shutting down machines that NOBAD marked as deviating from normality. Took about 4.5, 5 hours, and the threat was gone. In other words, NOBAD did a good job there. I didn't really think it would do a good job, but it did. WebEx is another thing. WebEx is an ASP. It's a small company down in San Jose that does online conferencing, and online conferencing is highly unpredictable. People might be pushing crap loads of data over during a conference, or might just be chatting, not generating more than 10, 15, 20K per second. NOBAD comes in handy here by finding out if something happens, if something impacts the quality of the conference, where it comes from. In other words, we know the load that a typical switch should have. The WebEx as an ASP uses data switches, layer 4 data switches that do a little bit of translation. What load has those switches? And we had it a couple of times where people actually pushed large amounts of data through one of these conference systems, and could be deviated without them noticing, because NOBAD rang the right bell at the right time. Our key design goals, and I'm really sorry, I have to make it very, very short now. Our key design goals are: we want platform and vendor independence. We're an open effort. It's all open source. There's nothing hidden. I know a couple of commercial entities are starting to sweat now. Don't sweat. Out there is a couple of mail servers that are way better than Microsoft's IIS, and they still sell some. So really, you're going to sell your appliance even though we're better. So we have platform and vendor independence. The only thing that we don't have plans on is running the aggregators or engines on Windows. That's not because Windows is crap, but that's because we don't have coders to do so. We have our data integration and aggregation has to become much better. We're currently using a couple of tools that Kaida uses. We're using mtrace. We're using DNS collect to collect DNS data. 5 minutes. I've been warned. And we're using Netlint. We want to extend that much more. Would be really cool if, for example, we're seeing strange traffic, run an nmap output and know this machine has a worm. We don't do that yet, but we might pretty soon. We want to go much further on the data analysis and visualization component. We're trying to get. We have a Python module for the XML processing finished. In other words, the XML data that comes from the aggregators, we can display that nicely on web pages. Looks really nice. It can be used to impress CFOs and CIOs and justify the extra $5 for the machines. We're very unfinished on a C++ class. The person who started doing that was a Microsoft user. He used Visual C++, and what we got back was this drag and drop, click me happy kind of C++ class that we had to clean out a little bit before we can publish it. And we've got a couple of .sos for Unix. They're almost finished. We're coding mainly on BSD. We have almost no Linux machines, so if anybody in here has a really nice grasp on Linux and wants to help out, let me know afterwards. Our next steps are, of course, as I said before, train NOBAD to understand more vendorware. Foundry, Nortel, Cisco, NetRangers. We have a little bit of a problem with Foundry. Foundry is not very open when we go and ask. We want to move our Unix OS sensors from Perl and Python to C. It's just a question: do you want to install one more interpreter on your machine, or do you just want to compile a C program? We want to provide a set of DLLs for Windows sensor development. So if anybody wants to do that, let me know. We're currently working on a hard version and under the OpenChip license, which will actually use a network processor unit, not network management unit, and be in a box. We'll just release the information, and then you can do whatever you want with it. And we'll have the first beta up on SourceForge in a couple of weeks. We were actually planning to have it finished before NANOG, but a lot of things, you know how it is. I'm trying to answer in my remaining 2 minutes, I guess. In my remaining 2 minutes, I'm trying to answer a couple of FAQs that I know will come after I climb down here. The difference between NOBAD and my current IDS, that's very easy. An IDS is an intrusion detection system. We find anomalies. An IDS can be part of NOBAD by providing NOBAD valuable information about the state of the network, but it's not an intrusion detection system. We're not focused at detecting intrusions. We're focused at detecting diversions from what we call normality. It's not a routing tool either. It can help to route. It is not. I got this particular question after a short email conversation I had on NANOG with Route Science. No, NOBAD is not a routing tool, and we don't intend to test the routability of packets with it. NOBAD is neither invasive nor passive. NOBAD is very active by pulling information from servers, but it's not invasive. You don't have to install it on a machine. You're just getting the syslog information from the machine. What is NOBAD being used for? I showed you 2 use cases. There's a couple more that I called a while ago and asked if they had a problem with me talking here about them using it, and the answer was a very friendly no. How long does it take for NOBAD to learn normality? That depends. In an infrastructure as big as T-Dial-In or Exodus, it will take a couple of months. In an infrastructure as tiny as my little network at home, which is a /27, it takes about an hour. After that, NOBAD believes it knows what normality is, and then then I start downloading porn again, and NOBAD starts whining. And the last question, how can I help? Who can I contact? The answer is here. The development team is available on NOBAD at basic.org. And these slides are on HTTP defensive.com. There's one thing I have to say. I'm working for Defensive Networks, but Defensive Networks is in no way affiliated with NOBAD, other than that they or that I set up the machine at Defensive Networks. So we're saving a little bit of bandwidth to our home DSLs by putting it on a commercial machine. But Defensive Networks is not responsible for what happens to NOBAD. That's me personally. Okay, I think that's it. Thank you a lot, and ask questions now.